Good afternoon, sir.
Yeah, welcome.
So much, sir. Thank you, sir. Good afternoon, sir.
Yeah, welcome. I want to give you something. I want to share something with you. We are still waiting for 2 or 3 people that should join us. Do you see what I'm sharing?
Yes, sir.
So I want you to respond. I give you just 10 minutes. 10 minutes to send it back to me. Is that okay? So we have 310.
I don't understand, sir.
That table.
Yes, sir.
You have to fill it, and you answer the question underneath it.
Is it possible we have the soft copy of it?
Sir, I'm in the car now, trying to get back to work. I went to work.
I got you. I got you now. I got you now. So what do you want to do now?
I will soon get to work. That's what I'm saying, that I might not be able to. I'm on my way now.
I've given it to you. I just want it. I want it back.
Okay, sir.
It's part of CA. It's part of CA. I want it back. Whether you're in a car, wherever you are. Don't fill it, answer the question, and send it back to me within 10 minutes.
But sir, we don't have like the soft copy or something.
Sir, how do we get the soft copy?
How are we going to get the soft copy?
Maybe you are seeing it now.
Oh, we should do it on our own place.
Do it and just send the answer to me. Or you want me to send the soft copy to you?
Yes, sir. Because of
How?
You can share it to the class group, like in the classroom. Then we download it from there.
What I'm saying, that you can do it now. If you have paper and pencil, do it and just give me the answer. That's what I need.
Ella, you have stopped sharing it.
I want to send to your WhatsApp.
Okay, sir.
Last engineer dinner. Oh, the group, do they have WhatsApp?
Yeah, the group has WhatsApp.
What is the name?
If you send it to Engineer Nuruddin, they will put it on the
Me
group.
add it to Jabi.
Yes, sir.
Yes, sir. Hello, sir.
Yes.
I can't see the question again. I just joined with my laptop. I just get to office now, so I just joined with my laptop.
I will send it.
Okay, sir.
No, you are seeing it now, me.
I've received it, sir. I'll send it to the group.
I'm still shining. I'm still shining.
Yeah, you can see it.
Mm.
Sir, you are not giving the power rating. Are we to assume any power rating? Hello, sir.
Hello, I think you will supply the power rating yourself, if I am not mistaken.
We have different answers.
Yes.
Shouldn't be. Hello, sir. If power rating is not supplied, what are we doing? Get different answers. Sir.
And the Global Foundation have been raised up on stage our president for that food. Sarah, where's the money at? 400, 400, 400, 400, 450. We can make it 500. We have a 500.
Mr. Satunji.
Yeah? What
Mr.
happened?
Timothy. No, it's Mr. Timothy. Mr. Timothy. His stuff is loud.
Yes.
Your
My what?
your background is loud.
Let me off my.
Thank you.
Engineer Adetunji. Lazarus,
Yeah, yes, sir.
any progress?
Yes, sir.
You have spent more than the time I wanted to give you.
Yeah, done, sir.
You are done. Okay. So you submit to my WhatsApp.
Okay, sir.
Your name, article number, and submit. What of Lazarus?
Hello, sir.
Yes.
Me, I did it with Excel. I was going to be acceptable. I was
And
going to be accepted.
just send to me.
Okay, sir.
Just send it to me with your matching number and name.
Okay, sir.
What of Teslim?
Yes, sir. I'm just typing my answer. I'm just filling my answer.
Just send. So that
Sir, me, I did it in a piece of paper, so I want to snap it and send it to you.
it's all right. Why the total energy you get?
23.7696 kilowatt hour.
Total amount income?
Total amount for 30 days, 713.09.
How do you get that one?
Total energy consumed times 30 days.
What of 16? Go?
Oh, 60. Sorry.
I think we don't.
Hello, sir. It's like we are
2,000.
Eh?
2,000. 785.
Okay, yeah. Engineer Adetunji Otigbodo. No. Odo. Engineer Adetunji Odo over 10.
Sir,
I'll give you 3 over 10. 3.
sir, no.
I'll give you 3 over 10.
When you call me, sir.
Eh?
I was still doing this when you call me. I was thinking you are asking me for the energy consumed in 30 days.
What of amount? Amount per month bill.
Per month, that's what I calculated now. For 2,785.
I thought you were saying another. Just submit to my listen. I want to see everything.
So today I'm at my store and I'm in my office. I'm currently signing a book for the girl. She wrote a kid's book. It's called The Right to Cultivate. And I'm before daughter about a big concept and now like published author. So Patty's here now, Patty's manager and then after
Can you see what I'm sharing now? Can you see what I'm sharing?
Yes, sir.
Are you there? Are you? Can you see what I'm sharing?
You can see it.
And so I think we are going to read before.
Yes, sir.
Let's take it one by one and read. I've seen that of Engineer Adetoji. What of other? Somebody should read question 1.
What is the parasitic load associated with the absorption, stripping, compression, and transport of the recovered CO2 to storage, and where will the additional power generation capacity come from? Do I continue?
Yes.
CCS plant require energy for flue gas fans, emil recirculation pumps,
Amine
recirculation pumps, amine regeneration, amine CO2 compression, CO2 dehydration, auxiliaries, etc. The amount of energy needed is broadly equivalent to the tons of CO2 to be captured and compressed. The parasitic load as loss in thermal efficiency of specific power plant is dependent on the efficiency and CO2 intensity of the unabated plants. For example, a coal CCS plant needs to capture and store more than twice the amount of CO2 per megawatt produced than a gas CCS plant.
Do you understand that now? They are talking about parasitic load associated with the absorption. No, we are talking about capture now. Carbon capture, stripping, compression and transport of the recovered CO2 to storage, and where will the additional power generation capacity come from? That's the answer to that. So the amount of energy that is broadly equivalent to the tons of CO2 to be captured and compressed. You want to capture CO2 and you want to compress it. You need energy to do that. So number 2. Continue.
Values of 9 to 12%, 20 to 29% for coal, and 6 to 11%, 10 to 80% for gas power have been reported for the next efficiency penalty. Percentage lower heating value, or LHV, lower heating value, and the relative decrease in efficiency. This really depends on material use, but on average, a number of about 20% is about right. So this means that if the power plant was 40% efficient in terms of conversion of fuel energy to electrical energy without carbon capture and storage, it will be about 32% efficiency with CCS. This will be reduced as CCS technology improves.
Yeah. When CCS technology improves, that will be reduced. Carbon capture storage is improved. So we have question 2. Who will volunteer to read question 2?
Hello, sir.
Yeah.
What is the main driver of private funding into CCS?
What is CCS?
Concern for climate change.
What is CCS?
I don't know, sir. Carbon capture
And storage.
Carbon capture storage.
Okay.
Yes, sir. Did I get it, sir?
Continue.
What's the main driver of private funding into CCS? Concern for climate change or enhanced oil recovery. If there was no gathering pressure under UNFCCC, especially Paris 2015, to drastically reduce CO2 emission from all sources, would the petrol and coal-based industries be putting any money into the environmental motivated CCS? Can I continue, sir?
Continue.
The main drivers for private fundings are an interest in being an informed consumer or user of this technology in the event that a sufficiently high carbon price or similar mechanism is in place to incentivize its deployment. 2, an interest in opening this potentially lucrative market and being able to supply equipment. And also 3, However, as EOR is predicated on assessing the cheapest possible supply of CO2, one wouldn't target power plant CSS in the first place, except in the absence of other options and with a very high oil price. Can you hear me, sir? Hello, sir.
Continue. I'm finished. Yes, I can hear you.
Yes, sir. Yes, I'm done.
Yeah. What can you say about what you have read?
He was asking if not for international policy.
What can you get? What can you get from what you have read?
Can you hear me, sir?
What can you garner from that?
Yes, sir. What I could gather was that we need to be informed, and there should be incentive to motivate individual users to acquire these technologies. If not, on a normal basis, nobody would want to invest into environmental motivated CCS.
So what is EOR?
Enhanced oil recovery.
Enhanced oil recovery. Yeah.
Oil recovery. Yes, sir.
Yeah. Yeah. So number 4. Question 3.
Hello.
Yeah, I can hear you.
Okay, so question 3. Once carbon is stored in a geological formation, will it leak out? If so, how long does stored carbon take to become harmless to the environment? Assuming that the storage location has been properly chosen and managed, it is highly unlikely that it will ever leak out. Therefore, once it has been sequestered, it is essentially harmless. The formation that we will be storing CO2 in are not empty. They are porous. They are porous rock, currently full of water. Once the CO2 dissolves into the water, it is no longer buoyant. So we tend to sink, not rise. Finally, over the course of perhaps 1,000 years, the CO2 reacts with the rock to form carbonate minerals. These are in general some of the most stable rocks.
So make comment.
Yeah, so what this is saying is that the CO2 are stored in the rocks, and then the CO2 also sink into water, which eventually stored in the rock, and the rock forms mineral, and the rock forms carbonate minerals, and generally some of them are most stable rocks. So it's talking about how carbonate minerals are stored. So how carbonate minerals are formed as a result of the CO2 sinking into water, and the water eventually stored in the rocks.
I can hear you.
Yeah, so I just explained it.
So
That's
the last thing,
finally, over the course of perhaps 1,000 years, the CO2 reacts with the rocks to form carbonate minerals. These are in general some of the most stable rocks.
What can you say about the last statement?
Yeah, it's telling us the duration, the reactive period of CO2 with the rocks to form carbonate minerals. And some of these carbonate minerals are the most stable rocks.
Okay, it's all right.
But I don't know what that stable rocks actually means.
Stable rock means rock is still stable. It's not. There's no crack. There's nothing. It still remains its integrity.
Okay.
So the carbon stored there will not leak. You guys see now?
Yes,
it's
sir.
stable. Do you understand now?
Yes, I got it, sir. Thank you,
Okay,
sir.
yeah. So number 4. And number 4.
Okay, I think number 4, the carbons that we intend to capture are mostly in the form of CO2. Will the CCS cause imbalance in composition of atmosphere, that is, reduction of some and increase of some? So then no, it will prevent an increase in the amount of CO2. For example, the carbon capture storage will not suck O2 out of the atmosphere with the CO2. Think of it this way. CO2 is 400 ppm and O2 is 210,000 ppm. If we burn enough carbon to increase the concentration of CO2 in the atmosphere to 500 ppm, which is sufficient to raise global temperature by 2 degrees Celsius, we drop the concentration of O2 to 900 ppm, that is by 0.05%. Hardly noticeable. In any case, the drop is a consequence of the combustion of fossil fuel, not anything we do with this CO2 formed.
So what can you say about that?
So it's trying to tell us that the CCS technology will not cause atmospheric imbalance. That is, in the process of capturing CO2 from the atmosphere, we will not eventually capture oxygen along the process. So it's trying to tell us the concentration 400 ppm. And what does the ppm means, sir?
Part per million. Part per million.
Okay, so it's trying to tell us the part per million of carbon and oxygen, so which is very, very far away from each other. By the time we increase the concentration of CO2 in the atmosphere to 500 parts per million, so we are not even near the part per million of oxygen. In summary, it's telling us that the carbon capture process will only capture the carbon. It will not reduce the concentration, or it will not tamper with oxygen in the atmosphere.
Number 5.
Faith, can you take number 5? Miss Faith. Okay, I think number 5 says, what is the monetary cost of CCS per megawatt hour of electricity generated from coal, oil, and gas? The short and the long term per megawatt hour electricity cost of low carbon fossil power from power plants where CCS is applied will be dependent on many factors. Among others, the capital and operational costs of both the power and the CCA part of the plant. First of a kind demonstration CCS plant, we have the higher cost than the anticipated cost of CCS plant in the commercial phase. Substantial cost reduction through learning curves when a large number of these plants will be built are probable, supported by the evidence from the multiple commercialization of analogous technologies.
Your comment.
Okay, so it's trying to talk about the cost in terms of money per megawatt hour of electricity, the cost in terms of money of carbon capture storage per megawatt hour of electricity generated from fossil fuel sources like coal, oil, and gas. And now the comment now says that it depends on the many factors, which include the capital and operational costs of both the power plant and the CC part of the plant. So maybe it's talking about the cost and the size of the plant. So he's now talking about the pilot technology. The pilot technology tends to be more costlier than the commercialized technology. So saying that if it is commercialized, the mass production will likely reduce the cost compared to a technology that is developed to test the possibility of the solution.
Number 5. Okay, number 5 continues in here.
Number 5, sir.
No, that one
Okay.
continues.
Okay, the number 5 continues from here.
Yeah.
Okay. One UK-based source for both low carbon fossil power costs and the sources for cost reduction upon commercialization is the CCS Cost Reduction Task Force report, which builds on the regularly updated comprehensive DECC cost of generation studies. Both gas and coal power costs are reported. Oil power costs are less relevant as the use of oil for power generation is very small in Europe. The report also shows that cost of CC per megawatt hour electricity as additional cost of low carbon fossil CCS power versus the unabated plant. At comparable plant utilization, gas power generally has a lower additional per megawatt hour CCS cost, as less CO2 needs to be captured and stored in a megawatt hour basis. However, this will ultimately depend on a lot of other factors external to this discussion. For example, the price at which financing is available.
Number 6.
Number 6. What is the monetary cost of CCS per hour of CO2? The cost of CCS per ton of CO2 is the difference between the per megawatt hour electricity cost of low carbon fossil and the unabated power plant divided by the amount of CO2 captured and stored per megawatt hour. Per megawatt hour low carbon fossil power produced. Coal power has a low. Sir? Coal power generally has a lower per ton of CO2 CCS cost with the economy of scale and higher CO2 concentrations in the flue gas. For instance, first of a kind CCS cost will be higher than commercial phase CCS. A reasonable cost might be 17 pounds per ton now or 35 pounds per ton with newer technology. However, the important point is that the increase in cost of the overall electricity supply system to 2050, assuming decarbonization, is lower by a factor of 2 to 3. If CCS is included, this is because it is necessary to build huge quantities of electricity storage for times when the wind is not blowing or the sun not shining. Fossil with CCS allows a cheaper overall supply system with guaranteed ability to respond to demand variability. I think this is more of talking about the renewable source of energy in futures to come.
Yeah.
So he's just trying to talk about the CCS, the carbon capture storage technology. It talks about the monetary value of it, how it is calculated. A reasonable cost might be 70 pounds per ton, but now it has reduced to 35 pounds per ton because of the advent of renewable energy, the solar, the wind.
Let's go to question 9.
Question 9. What are the prospects of carbon capture storage CCS that can be retrofitted to existing power stations rather than purpose-built plants with integrated CCS? Existing power stations can be retrofitted with post-combustion CCS on the flue gas. Often the steam and power needed to run the capture plant can be drawn from power plant utility system. The scope and complexity of the retrofit will be dependent on the state and the CCS readiness level of the power plant. Carbon capture storage readiness can be defined at different levels with available plot space, installed ties-in, CO2 pipeline corridor, etc. It is probable that it will not be attractive to retrofit old coal plants with lower efficiency and a limited residual technical or economic life. Post-combustion options are best here. For example, amine scrubbing or calcium looping.
Number 10. Question 10.
Given the time scales that are demanded by international agreements, is it your impression that markets such as India and China will look at the West to buy technology, or will they develop their own, or even license it back to Europe and the US? This will depend on which countries progress first and fastest in demonstrating carbon capture storage at scale in real projects. In any case, the position of CCS markets such as India and China, currently not in the same stage of CCS demonstration, will change over time. It is likely that in the first instance, for the first set of large-scale full value chain demonstration projects, India and probably China will look to buy technology from countries and companies that are more advanced in developing and demonstrating CCS technology. So I have a question here.
Finish reading it.
Yeah, we said India and China, they will look forward to buy from a country with more developed CCS technology. What country is that? Is it the Germany, US?
Yes, now.
Okay, sir. Okay, sir.
Question 11. Question 11.
Number 11, which has greater potential, pre or post combustion carbon capture storage? With the differences in CO2 sources in different industries and carbon capture storage on existing and new build, it is probable that the different CCS technologies will develop and find their place. Specifically, post-combustion will be suited to retrofit, and pre-combustion may have its place in low carbon hydrogen production. It depends on the time scale and the particular niche. In the short to medium term, it would appear that post-combustion technologies are more viable than pre-combustion technologies. The oxy-fuel combustion option should not be forgotten either. So I think we should be in the post now. I think we should be in the post-combustion now, like the world we are living now. We should have left the pre behind.
It depends.
Okay, sir.
Number 12.
What is the current biggest roadblocks to carbon capture storage
Let
implementation?
Faith read now.
Lazarus,
Mr.
please read.
Tessin. No, Faith. Hello, Faith.
Yeah, on number 12.
That fit?
Hello?
Hello, is reading.
Yes, go ahead,
Yeah.
ma.
Okay.
Who is reading?
Number 12. What is
Who is
Faith,
reading? Who is that?
Faith is reading.
Faith, okay.
Yes, faith.
Okay.
Yes, the faithful faith.
Okay, number 12. What is the current biggest roadblock to CCS implementation, and how might this be overcome? So CCS is a combination of technologies deployed solely for climate change purposes. And CCS will not really be viable until there is a competitive penalty for carbon emissions or a price on low carbon products produced with CCS, electricity, among others. The absence of either of these in most countries is the biggest roadblock to implementation of CCS at scale. Financing the project, and here the most important thing is credible, long-term commitment from government. Also, misguided opposition from some environmental organizations.
Comment? Your comment?
Okay, so according to this question, the current of the that come from some environmental organization, and even sometimes the commitments from the government. So The question is, how can this be overcome? That is, how can we overcome all these roadblocks to CCS implementation?
Yeah, is that all?
For me, the biggest how this can be overcome is when there is more credibility coming from the government and also from the environmental organizations.
Okay, thank you. So we have gone through that now. So you go through it,
Hello, sir.
through all those. Yeah.
Are we going to get the slide also?
You have it already.
Yeah. Yeah.
You have it now.
No, sir, we don't have it though.
Yeah, I will send it on.
Okay, sir.
Okay.
Sir, please can we get AOC, like where we can focus on for the exam?
AOC, that page.
Yes, sir.
Page.
It is page, sir.
You are
Yes,
looking for
sir.
AOC. You are looking for AOC.
Yes,
Eh?
sir.
Make sure you read very well.
Yes, sir. I'm reading. We are all reading very well, but we just need something, maybe like
I'm trying to concentrate. That's why I'm doing the tutorial now. I'm trying to where area that I think you should be strong. That's why I'm trying to focus on now.
Okay, sir.
Okay. So I think we can have the last on Monday, Abby. Is that okay?
Monday public holiday, sir.
Okay, what was Tuesday?
Yes, sir, no problem. Tuesday.
No problem. Tuesday, sir.
Okay, you can write it on Tuesday so that if other lecturer have anything to do, they can. But make sure
Yes,
you submit all my assignment. That of Timothy, I think I've seen it now.
Sir, what about mine?
Who was that?
Riches.
You only have been here since now.
Thank you, sir.
I think we are 7 today. So we meet on Tuesday.
All right, sir. Thank you, sir.
Submit the assignment.